good afternoon, session chair and everybody. So I am from academic institute, so I will talk about research. So sorry if you get bored. So here, yesterday one speaker, Dr. Babur, said about arsenic problem in Ganga Basin plan. So I am not going to in details the problem, what is the problem with us. So I will talk about a solution. He also proposed in 8 solutions. There was 2 solution was the household filter and domestic filter. So I will talk about these 2. Here we use the natural material and with some tricks by increasing some capacity of this natural material to absorb arsenic by engineering knowledge we gain. So myself Abhijit Maiti, I am a assistant professor at IIT Roorkee. My student Nishant joined. This work I started when I was in PhD scholar. So I also acknowledge my supervisor, Dr. Shishendu De, IIT Kharagpur. So we develop a household filter first, and then now we are starting to domestic filter to do research. And further we observe that in groundwater in the district of West Bengal, such as Midnapur, Purulia and Bankura, they have laterite material, and we have no problem such in groundwater arsenic. We have never found arsenic in that location. So that we thought might be laterite material can be used as a filter media. So laterite material is not a standard material. So we have collected for different locations with the various composition. So we have collected from Kharagpur, Bankura and Purulia. There are 4 samples, and you can see the wide variation in the iron. This is the, you have a, okay, so not here iron. So this is the iron composition around is 40 to around 30% was there with the varying this composition. And then we did the physical properties. The surface area is around 17 to 6.5 meter square per gram and 0 point of charge, so around 6 to 8. And we use the real contaminated water collected from South Chobbish Pargona, West Bengal, and the concentration was way high from who the recommendation is 10 microgram per liter, but it's way high. It's a 36, 40, 45 times, 46 times higher. And we did conduct your batch experiment, and this is we fitted some model, and this is the batch experiment, and then we did the column experiment for synthetic water of arsenic 5 and arsenic 3, because in water you will have both arsenic 5 and arsenic species are there. Arsenic 3 is in the neutral state. It is very difficult to separate, and also it's more poisonous than arsenic 5. So we did the experiment and the column study for longer times of so you can see, so the concentration, initial concentration or around the 1000 microgram per liter. We have taken a little higher concentration, and we observe the natural material for laterite we use, it's give very small amount of purified water. So then we started to, that's you have use also your real contaminated water, and we observe that it is 106 bed volume can be treated Indian standard of 50 milligram per liter. So it is not usable much if we not straight away if we use the laterite. Then we started thinking what's the problem is there. So then we saw that the low specific surface area and low pore volume and low surface charge. So inside there iron is there, but iron is not exposed to the surface, so it's not able to catch the arsenic. Then we did some very simple chemical treatment method, acid and base, and then we observed the drastical change in surface area. You see, this is a 10 times surface area improvement. It was only 17. Now it is 1080, and it was 8. It's almost 10 times improvement occur. And you see the iron concentration we observe. There is iron 45. Because we are not putting any inorganic material, means in terms of metal, so there is no increment of metal concentration as it is. But the chemical composition of the inorganic material has changed drastically, and the surface exposed, means the per unit surface area, the surface site per unit surface area increase a lot more. So that is also we can calculate surface charge by different method. We did this. So this is the main highlight of this. And we did the expensive study of the chemical treatment, how to modify our treatment method. I am not going to in details. The last one we observed, this is the highest absorption capacity, even it is better than activated alumina used in the market. as a commercial. The another commercial is the iron hydroxide, but it is a costly in India market. So this is the highest arsenic 5 around 24. So it was in the raw laterite 0.31 milligram per gram. Now it is 24, means almost 40-50 times increment occurred due to this chemical treatment. So this is the your maximum capacity. And this is, we did the 50 gram in research, 50 gram batch. And again it is 20 gram in a batch, because the scale up gives the, we have a lot of problem in future. So we did the both, it's from 50 to 20 kg. So we observe the surface area is not much change. And so we are getting this with the same chemical, treatment method sufficiently high. So we did up to 40 kg also per batch. And we observed there is no such deviation from your my laboratory research data. So that here we did the contaminated groundwater CGW, and here we have taken different bed of raw laterite. So this data is a raw laterite. So it's a very small amount of water can be treated. But when we are taking the, here is a, you have a 30 centimeter bed height. But if you have a only 4 centimeter bed height, this is the star, we have a lot of improvement is there. And again, we observe there is a blue circle. The blue circle is here, you have a, I think blue is, here is a, sorry, this is red is showing here. So this is the 4 centimeter, only 4 centimeter bed height. It is a giving the best result. And if I use raw laterite, this is the 30 centimeter bed height. Yeah, this is the 30 centimeter, way higher, much higher bed height, but the performance is not superior compared to treated laterite. This is TL for treated laterite. We did the 3 cycle. This is the first cycle. This is the second cycle, star 1, a little reducing, but still there is a performance is good. And another observation we observe, if we have a raw laterite and same 4 centimeter treated laterite both, so because raw laterite is drastically reduce the arsenic, but it's not go to the our permission limit. But if I use both raw laterite and treated laterite together, the performance is hugely improved. If you have the 4 centimeter and 30 centimeter both. So if I add this column and this column, the performance is here, the better. So we can use still raw laterite and to improve our performance of treated laterite bed. So this is, I have compared with the activated alumina available in market. So this is the, your red is showing the activated alumina, and this is, this is the raw laterite plus treated laterite. So we have can able to 1050 and compared to only 170 bed volume. So this is the smart solution of saying the ATM in Delhi might be, ATM of water might work in Delhi, but it will not work in Kolkata. So there is a smart solution, the smart problem we have to synchronize one to another, and then we can do. I think that's the Kolkata for Kolkata, we have to think about this. Sorry for. So we did some household filter we given to the village in Barasat, Uttar Chaubish Pargana, in the school. So this is the study for up to 220 days. This is the raw water, always is the within the 100 to 400 microgram per liter, and we always observe it is less than 6 microgram, so it is way below the WHO standard 10 microgram per liter. So it's working perfectly, and we have a data only 220, but it worked for 3 hours, 3 years. And we replace the material, and then again it's working. So it's almost 7 years of research this. So this is the raw and purified water, given a sample. So we have, this is your filtered water, this is the raw groundwater, varying with the lower value and higher value. I have given only 480 microgram to 495 microgram of hardness. And this is arsenic, is 0.055, means 55 microgram per liter to 370 microgram per liter, it's varying. And we have always your purified water within that 0.006 microgram per liter. So these are the filter, this actually this WHO also, UNICEF the sponsored this research, and also DST sponsored this research, and they are working in a, this is the your school, and here is a household filter the actual household filter. So we observe that this treated laterite is not capable much absorb arsenic 3. So now I have started how to improve the arsenic 3 again, then I can then work for this filter for 6 years. I am ensuring, because we got a technology. So in a particular in South Africa, there ferromanganese ore and India, both huge amount of ferromanganese ore available. This is the, you can as a waste. So that contain almost 30% manganese. So there is a several researchers trying to how to extract this manganese to usable, but here we am proposing I can straight away ferromanganese ore we can take, and I can develop treated laterite with ferromanganese ore. Then we can drastically increase the arsenic 3 absorption performance here. And we did the, sorry, okay, why not it's coming? Okay, sorry, this data is not coming anyway. So actually, if we have a ferromanganese, we can treat laterite along with ferromanganese ore, that we improve the arsenic 3 from 8 milligram per gram to almost 20 milligram per gram. And the performance, we can double it, and particularly in groundwater, we will have a arsenic 3 is the 70%. So major component in arsenic 3. So if we improve the treated laterite using this ferromanganese ore, then I am sure it can run for another 3 years more. You can double the performance of the filter. So it is way above than activated alumina presently used worldwide. Thank you very much. This is my conclusion, that if we have an iron content in laterite is much more, then we have a better, we can prepare material. So thank you also.